Okay, yesterday we talked about how you graph a parabola when it's in its standard form. And now what we're going to do is talk about graphing that same parabola, but we're going to shift it a little bit. To remind you a little bit about what we talked about, we said that a parabola has two forms of the equation. You have y squared equals 4px and x squared equals 4py. Alright, so if you have a y squared term, your axis of symmetry is horizontal. And if you have x squared, vertical. Also, you want to look at what your p-value is. If p is positive, then it opens up or right. If p is negative, opens down or left or left. Okay, now I'll get into explaining a little bit more about this as we go on, but what I want to show you right now is that if we're looking at this equation, say y squared equals 4px, that's when the vertex is at the origin. So we have this situation going on. And to give you a more specific example, let's look at, for instance, y squared equals 12x. Well, the first thing we want to know is what's p? Well, all you do is you take the coefficient that's in front of your x term and you divide it by 4. So 12 divided by 4 equals 3. Okay, so p equals 3. And look at this for a second. P equals 3, isn't that true if we put this back into the equation? 4 times 3x, doesn't that equal 12x? So, you see, P is 3. Okay, so we know P is 3, that means it's also positive. And since we have a y squared, it's horizontal. Since P is positive, it's going to open to the right. We know our vertex is at 0, 0, P is 3, so I go for my vertex, I go 1, 2, 3, put a dot. This is P, which is 3. Now I'm also going to go up 2P and down 2P. So if P is 3, 2P equals 6. So I go 1, 2, 3, 4, 5, 6. And I go 1, 2, 3, 4, 5, 6. And then I'm going to graph it. And that's how you do it. Okay, that's for an equation where the vertex is at the origin. So what I want you to look at is how can we evaluate this situation where our vertex is going to be anywhere. Well, the equation is actually, let me erase that, that's not very neat. Y squared, sorry, long day, y minus k squared equals 4p x minus h. Okay, so k is going to be the y coordinate of the vertex, h is going to be the x coordinate of the vertex. In this case right here, there's 0, 0. So that's going to give us y minus 0 squared equals 4p, but in this case p is 3, so I'm really looking at 4 times 3, or 12. And then that's just x minus 0. So you see, they're the same thing both ways. Y minus 0 squared is y squared. 12 times x minus 0 is really just 12x.